All right, so ratios are one of those things that look like a fraction. It compares two quantities. So like a ratio is just some number over some number. Like you might have a ratio, when you start looking at colleges, you'll want to look at what is the ratio of teacher per student. Okay, so in this class, we have one teacher for every, I think there's about 14 of you in here. So one teacher for every 14 students. So that's a ratio. Would you want to go to a college that's one teacher for every 100 students? No, that's not much attention, is it? So, but sometimes people choose those schools, which is okay, but I'm just saying you'll be wanting to look at that and see how much attention you can get. That's just one example of a ratio in real life. All right, open this up and let's look at some examples that I have in here. A ratio is a comparison of two quantities by division. It's a comparison of two quantities by division. Okay, so let's look at these. Write the ratio of the first measurement to the second measurement. We also want to know what order they want. They want first one over the second one. All right, anybody play tennis in here? No. Oh, no? All right, so tennis racket's about this big. Anybody like ping pong? No. All right, good. We should have ping pong contests. That'd be fun. Ping pong's about this big, okay? So they want to know what's the ratio of the tennis racket to the ping pong racket. All right, well, here's the tennis racket, 2 feet 4 inches. Here's the ping pong paddle, 10 inches. Now the problem is you need to put them in the same units here. So if you have 2 feet 4 inches, what do you take the 2 by to get it into inches? Inches. Times it by what? How many inches are in a foot is what you need to know, 12. So you first need to do 2 times 12 and figure out how many inches that is. 24, and then what's 24 plus 4? 28. So the tennis racket is 28 inches. Now that I have inches here and inches here, now I can set up my ratio. So we want, the ratio wants tennis racket over ping pong, T over P. Am I going to write 2 fractions or 1 fraction? 1, because I'm only writing one ratio. So tennis racket is 28 over ping pong, which is 10. Now, the other thing they probably will want you to do is reduce them, okay? No, I guess we could in our final answer, but that's fine. You can leave it like this. Okay, the one thing we want to do is reduce them. So those yellow calculators are handy for this. So type in that fraction button, and then hit 28 divided by 10. You're going to want this for this. So when you use your EOC test, you get to use this and Desmos, and this is one thing that this does better than Desmos. So you would hit this button and you would hit 28 and over 10 and hit enter. And it keeps it as a ratio. See how it's 14 over 5? If you got 2 and something, then you want to change the form. Did anybody not get 14 over 5? Because I can show you what buttons to hit. Anybody not get that? Okay, so your answer is 14 to 5. That would be the final ratio in lowest terms. All right, next one you want to do, the height of a ping pong net. Okay, height of a ping pong net's about this tall, 6 inches. The height of a tennis net comes up to your waist, so 3 feet. Once again, different units. Let's take this and put it into inches. So unless it tells you, you don't really know which ratio you want. You can do whichever one you want. So what's 3 times 12 going to give us for inches? 36 inches. Okay, so now I have 6 over what? 6 over 36. Very good. And that can be reduced. And what does that reduce to? 1 over 6. Very good. Anybody got any questions on that? All right. Good. Let's move on. I'm going to skip number 3 because I think you have the idea. Let's go to proportions. So here's the difference with a proportion. A proportion compares two ratios, and I think I have I have a definition on the inside. But a proportion is when you take a ratio and set it equal to another ratio. That's the difference. A proportion has two ratios. A ratio is obviously only one. All right? So let's open this up. A proportion is I called it an extended ratio. That states two ratios are equal. So two ratios are equal. You solve proportions by cross multiply and divide. Everybody always seems to remember cross multiply and divide. So solve them by cross multiply and divide. Okay, so let's see if you all remember how to do this. And once again, why are we doing this in geometry? Because we're going to compare ratios of sides, and then we have to solve for unknown sides. So that's why we got to know how to do proportions. Okay, so number one here, we have one ratio, 9/2, equal to x over 16. So see on this one how there's an x here? So now you have to solve for something. So you're going to take, it doesn't matter which order you do, but you cross multiply. What's 2 times x? 2x, set it equal, and then 9 times 16 is the next thing you want. 144. And then you do what? Anybody remember?
Divide by 2.
Divide by 2. Good job. Divide by 2, divide by 2. So x is equal to 72. Anybody need a hand on that? Okay. Now, what's the difference on this one? See on number 2 how it has x plus 1 down there? The thing you have to remember is that if you have more than one term in either the numerator or denominator, I would put parentheses around it right away. That way you remember you're going to have to distribute on this one. So we're going to take 5 times x plus 1. So that means I'm going to write 5 parentheses x plus 1, because the 5 has to get multiplied by the whole thing. And then that equals, what's 15 times x? 15x. Okay, you at this point can put 1 on line 1 of Desmos, 1 on line 2. You guys, a lot of you do it by hand, so I'm going to keep going by hand, okay? So what's 5 times x? 5x. What's 5 times 1? 5. So I have this is equal to this. What's your next step in solving? Yep, I got x's on both sides, so I got to move these x's to this side. So minus 5x, minus 5x. So 5 equals, what's 15x minus 5x? 10x. And then divide by 10, because 10's the one with the x. Divide by 10. And I think Alex's face is like, oh, we're going to get a decimal or a fraction, right? Because what's 5 divided by 10? 0.5. So 0.5 is equal to x. So yes, sometimes you do get that. That's fine. All right, number 3 is a classic one that they like to put on the ACT. So let's go over number 3 anyway. All right, on number 3, just right there. Thank you. Tell her I'll run them down in between classes. All right, number 3, it says members of the FFA are selling boxes of apples and oranges to sell for a fundraiser. Okay, so picture this. You're selling apples and oranges. They're separate boxes. Do things always sell at the same rate?
No.
No. Which one would you all pick? Oranges?
Yeah.
Apples.
Apples? Depends on what apple. So, okay, did you all know apples have different flavors?
Yes.
Yeah, there is a big difference. Okay, so apples and oranges, you got boxes like that. So you know they sell at different rate. So what rate do they sell? Here's what they said. The ratio of numbers of apples is 3, the number of oranges is 4. So their ratio that they've already run this sale, which one sells better, apples or oranges? Oranges, and that was in here too. So are they only planning on selling 3 boxes of apples?
No.
No, that just means for every 3 apple boxes, how many oranges? 4. That's what that means. So picture 3 apples, 4 oranges. If you sell more than that, you get another 3 apples, 4 more oranges. If you sell more than that, 3 more apples, 4 oranges. See how the oranges are going to add up quicker? Okay, so they plan to sell a total of 600 boxes of fruit, but we don't know how many of each. That's what we're going to figure out. So how many of each type? Okay, well, here's the problem. You got it, this is a total, right? Do we have a total when we say 3 and 4? No, but could we get a total? Yeah, because what's 3 plus 4? 7. So we got to do oranges and apples separate. Let's do oranges first, because they were most popular in here. So here's what we're going to do for our oranges ratio. We're going to take oranges over the total. Okay? So tell me baby little ratio with what they told us. How many oranges out of how many total boxes? No, how many oranges?
4.
4 out of how many? 4 out of, what was the total here? 7. 4 out of 7. All right, now we want to take 4 out of 7 and put it with our big number. So tell me, the 600's the big number. That's the total number we want to sell altogether. So where do you think 600 goes? The bottom, because it's a total. So you make another ratio here, and you want to know how many would that be out of 600. Does that make sense? Okay, so you got oranges in total. You have to stay oranges to total the whole time. All right, now we got one of those proportions. How did we just say to solve proportions? Cross multiply and divide. Good job. So 4 times 600, 2,400, and 7 times x, 7x. Our number has to be smaller than what? What can you have for like a domain, like a good answer? Our number has to be smaller than what? Has to be smaller than 600, yeah, than the total boxes. So if we get a number bigger than 600, we got a problem. All right, so 2,400 divided by 7. 342? Yep, 342.8. Okay, so we'll say x is approximately 342. And that would be oranges. Now, did we figure out the apples? No. You can. From here, it could be pretty easy. Or you could set up a proportion. How many total did we plan to sell? 600. And if I know 342 are oranges, can I figure out how many apples without doing a proportion? Yeah, subtraction. 600 minus 342. So no proportion needed to get the apples. So 250, I have 258, but remember that's a rounding, and that's apples. All right, cool. Yeah, whichever. It's all right.